The world is changing more rapidly today than ever before in human history. Technologies that were the stuff of science fiction just 50 years ago are science fact today. Communication networks now instantly connect distant nations. Computers have revolutionized design and production, creating an international language. But nowhere is this revolution more critical than in transportation. The transport of goods and people is one of the driving forces in any sound economy. Farm to market, factory to port, country to country, transportation gets it there. Throughout the world, scientists, engineers, and technicians are at work to improve the design, construction, and durability of streets and highways. They are conducting research, testing materials, learning from past mistakes. And this knowledge benefits not just one country or area, it is available to the international community through a process called technology transfer.
That one of the problems that we have is not a lack of information, it's this tremendous wealth of information. And technology transfer is all about selecting the right information and delivering it to the right person.
The United Nations has stressed the need to make technology transfer and training in transitioning nations a priority, and several nations and transportation agencies have in recent years renewed their commitment to the process. In the United States, the Federal Highway Administration has established 50 technology transfer or T-square centers serving virtually all the states and territories, including Puerto Rico. The T-Square Clearinghouse, operated under contract to FHWA by the American Public Works Association, acts as a central dissemination point, spreading information to the T-Square centers. This network provides technical support for nearly 38,000 U.S. agencies who are involved with local roads, bridges, and public transportation programs. One phone call taps into an up-to-date database and referral source. The Organization for Economic Cooperation and Development, OECD, promotes cooperative activities to strengthen the economies of its 24 member nations as well as others.
The OECD countries, which are the industrialized nations, feel that they are more and more forced to put policies of technology transfer and technology diffusion into practice. And this because of many reasons, many economic reasons, social reasons, educational reasons.
The Permanent International Association of Road Congresses, PIARC, and the International Road Federation, IRF, have long promoted technology transfer within the international highway community through educational programs, conferences, committee work, and publications. And the newly formed SPRINT, Strategic Program for Innovation and Technology Transfer, deals with the unique benefits and problems of the single European community. The countries of North and South America are linked through the Pan American Institute of Highways, which was formed in Mexico City in 1986.
The Pan American Highway Institute brought us. Now we have to offer some programs to the other countries. And so we are not only thinking in ourselves. Another thing is to know what other countries are doing and what Latin American is doing. So this is very important for us.
The goals of these and other organizations are to help nations throughout the world solve their transportation problems, to save lives by helping all nations develop safer roads and traffic systems, to encourage adoption and adaptation of useful technologies, to promote economic development through improved transportation, to move state-of-the-art research to state-of-the-practice application.
It takes time and patience to read through the layers of cultural difference and so on, but in many cases there are many people in the third world who, given the opportunities and the training, could in fact do a very, very good job for themselves. Now, that takes time and patience, and of course it takes money. But I think we have to persevere at that. But we can't rush it, and we can't hope to get results in the period of sort of 1.5 to 2 years of a project, come in, bang, and go out again. It's really building up a sort of the human infrastructure as well that's part of it.
Highway professionals face a number of concerns in the decade ahead: modernization, maintenance and operation of existing structures, transportation problems in urban areas, quality of life issues including traffic safety, energy conservation, and environmental impact, internationalization of roads, for example in the European community, and the increasing authority of local and regional highway agencies within each country. The tools and techniques of technology transfer are as varied as the nations using them. In a survey of selected OECD countries, more than 50 transfer methods were cited, from electronic bulletin boards to fairs and exhibitions. The list was long and creative. The most popular techniques included libraries, training, experimental and demonstration projects, publications, including newsletters and journals, audio-visual aids, and one of the most popular tools, the circuit rider. These traveling promotional workshops and seminars are effective in delivering the latest information at the user's location.
The roadshow, or circuit rider concept, of transferring technology is proving to be a most successful, acceptable, effective, and cost-effective method of transferring roadway construction and maintenance technology to local public works agencies and/or any other groups around.
Computer applications expanded to include such techniques as specialized software packages, online databases, centers for distribution and maintenance of highway-related software, electronic bulletin boards, and the still experimental computer conferencing. A successful use of this tool is the International Road Research Documentation Service, sponsored by the OECD Road Transport Research Program. Begun in the early 1970s, this public access database now contains nearly 250,000 records. It is updated monthly, and information is available in French, German, and English. Ad hoc assistance and training programs continue to be effective. And, in fact, one-on-one continues to be an essential ingredient to the technology transfer process.
In technology transfer, we have many mediums in which we use to transfer the technology. Certainly, probably the most economical one from an upfront cost point of view is training, is the production of literature to send out in the form of pamphlets, technical advisories. The most expensive, yet the most effective, is always on a one-to-one, face-to-face. It's a hands-on demonstration of equipment techniques. I think that what we have to do is to be able to better prioritize our resources so that we can address those areas that need it the most. And in some areas, if we see that the best way and the most direct way is to have a hands-on demonstration of technology, I think we'll go to it.
Meetings, congresses, and symposia provide opportunities to share ideas, exchange information, and make and renew contacts. 2 international conferences, sponsored by OECD, fulfilled all of these expectations and more. The Seminar on Technology Transfer and Adaptability in Industrialized Nations in the area of highway transportation was hosted by the United States in Orlando, Florida in November 1990. Delegates from around the world gathered to identify and document the principal technology transfer techniques, methods, practices, and costs as they exist in the OECD countries. and to prepare recommendations by member nations that would promote the rapid flow of highway technology within and among those nations. Just 10 months later, a second seminar in Seville, Spain, focused on the special challenges of the transfer and adaptability of technology in developing countries and countries who are in a transitional phase. Several hundred attendees from both OECD and non-OECD member nations spent 3 intensive days at each seminar examining the process of technology transfer, evaluating from past experiences, and planning future strategies. Both seminars featured thought-provoking reports from speakers representing all corners of the world, and the environment encouraged free and open discussion. A consistent theme was removing barriers to effective technology transfer.
Let me summarize a few for you. The first is resistance to change, and this is in the form of institutional resistance, because it's always comfortable to persist in doing what you've done for the last 50 years. Change is dangerous, change is risky, and change forces you to abandon your comfortable position. The second is a basic conflict between the objectives of self-sufficiency, self-reliance, and dependence on imported foreign technology. Now, up to a point, one can understand the rationale for self-sufficiency and self-reliance. But when it becomes a barrier to technological progress, then we must take a second look at the needs, at the objectives that drive self-reliance. A third factor is quite often the policies of lending institutions and donors. They tend to perpetuate dependence on foreign technical assistance rather than the development of indigenous capabilities. And I would say finally is the nature of technology itself. Quite often it is not the appropriate technology, and when technology is adopted or foisted without consideration of the local conditions and local capabilities, then it generally turns into a disaster.
Pointing out that technology transfer is often more art than science, speakers at both conferences stressed that it is critical for suppliers to understand user needs.
I would say, first of all, an understanding of the countries, the cultural situations, logistic situations, and the financial situation. Secondly, is an understanding of the construction industry, how it operates, the kind of monopolies that exist, practices, methods, and technologies. And thirdly, a clear-cut definition of the level of absorptive capacity of the region. And by this, I mean in terms of the ability of the recipient country to receive and practice whatever technologies have been transferred. We must bear in mind that despite all the various components of technology transfer, unless the technology is properly received and unless the recipient can practice the technologies on their own, it's not fully transferred.
More basic but still manageable problems stem from language barriers and cultural differences. Viewing technology transfer as a process rather than a one-time event, delegates worked with a model designed to overcome many of these obstacles. The steps include problem identification. This may be a request for assistance by a user or an expressed area of concern by a provider or financial supporter. Research and development, looking for answers to the problem. Assessment. Will a proposed solution work technically, economically, culturally? Planning. Laying the foundation for action. Packaging. Which of the possible tools and methods are best for our situation? Promotion, providing a two-way dialogue to encourage acceptance of the program. Implementation, the program goes online. And finally, if all is successful, there is adoption of the new technology, the transfer of know-how from supplier to user. Success stories demonstrate that the process is working. Shui Tong-mung, General Manager of Public Works in Myanmar, formerly Burma.
We had a bridge engineering training center project and then bridge construction project in the field of pre-stressed concrete. We get grant aid and assistance from the Japanese government a few years ago. Very, very successful compared to other types of technology transfer.
Since Saudi Arabia began working with international contractors and consultants in 1963, over 100 contracting companies and 14 national consulting engineering firms have formed within the kingdom.
The Kingdom of Saudi Arabia was seeking for technology transfer since its beginning in developing its all fields. And as in the Ministry of Communication, we are looking for technology transfer from developed countries, and we adopt the one that suits us. And nowadays, we feel that we can transfer technology to other countries. This seminar gives the opportunity for us to meet with international technology transfer professionals, exchange information with them, and also it gives us the opportunity to meet some of the technology transfer communities and learn how they achieve their transfer of technology.
The National Road Administration of Sweden provided technical assistance to the Ministry of Transport in Zimbabwe in the construction and testing of 4 roads, totaling 150 kilometers. Bjorn Terstad, Deputy Project Director for Sweden, reported that work was successfully completed and long-term monitoring and evaluation is planned. And the work continues. Rapid advances in communication and computer technology are linking the globe, making information accessible to every corner. As the new millennium dawns, we are taking firm steps toward the establishment of a true global community, a world of shared knowledge, shared ideas, shared dreams.
We got involved in technology transfer in 1969 in Federal Highways when it first got started. We didn't call it technology transfer at the time. It was training. It was promoting new technology. Then somewhere along the mid-70s, technology transfer came on board, and now today it's getting a lot of high emphasis. But it's nothing new. It's just a new name for an old tradition that we've always done, trying to implement new technology, the use and deployment of new technology, be it in training, be it in issuing of publications, or be it on one-to-one demonstrations. We also see another reason for increasing our technology transfer efforts around the world is because just as being a good neighbor.
We need to work more closely and coordinate with other nations in terms of new technologies that would be of help to us. Hopefully other nations will help us in terms of giving us new ideas, new technologies, and we'll be able to do the same for other nations as well.